Okay, in that last video, we were working on the function f of x equals 1/8 x to the 2/3 times parenthesis 9x squared minus 8x minus 16. We found the zeros and the values of x for which the first, second, and the function f, the first derivative and the second derivative did not exist. And those are the critical numbers. Now we're going to use them as we continue along these lines. The first thing we're going to do is draw this fancy diagram using nodes 81, 82, and 85. This is just like we did in the last problem, the last example before the last video. So we're going to only interested in listing f prime of x in its factored form here. And below that, we'll list f double prime of x in its factored form. Well, it turns out I can't factor the top, so I'll think of the top as a factor all by itself. And let's see. Then we're going to draw a number line, and we're going to first list the critical numbers of f. We got those from f prime of x. We had -4/9, 0, and 1. And then below that, we're going to list we'll divide up the number line for f prime of x there, because we're going to find about increasing and decreasing in those different regions. Okay, the critical numbers of f double prime. Well, no, we're not there yet. Let's figure out the signs in each of these 1, 2, 3, 4 regions of f prime. We have negative here. Then for the second region, the first derivative is positive, and for the third region, the first derivative is negative, and for the last region, the first derivative will be positive. Okay, so in each of those regions, we can see that first we have a negative, so we have a decreasing function. Then we have a positive, so we have an increasing function. Remember, that's a positive slope. Then negative decreasing function, then positive increasing function. All right. Now, let's bring down the -4/9 and label it for what it is. It's a local minimum, because we have decreasing to increasing. Here we have a local maximum at x equals 0 because we go from increasing to decreasing, and another local minimum at x equal 1. Great. Okay, now let's look at the sign graph for the two regions that we acquire for f double prime by using its special numbers. And we get, let's see, in the first region we get positive for the second derivative, and in the second region we get positive again. So what does that mean? What does that mean? I want you to notice the denominator is always going to be positive for f double prime because it's x to the 4/3. You can imagine that as x to the 1/3 raised to the 4th power. You raise anything to an even power, it doesn't matter what the base is, your answer will be positive. That's why we have positives on all the bottoms. So we have concave up in this first region from -infinity to 0, and concave up again for the region from 0 to positive infinity. And that was all acquired from the second derivative. Now, I want you to notice that since x is equal to 0 has the same concavity on both sides, it is impossible for that sucker to be a inflection point. Remember, to be an inflection point, you have to have a change in concavity.